In this video, I would like to work through just a couple of problems in which we're given an equation of a linear function or a linear equation, and our goal is to graph this equation. Now, we're going to use the slope and the y-intercept of each line to generate the graph of the equation. So we know that the equation of the line, which number one is already in this form, the equation of a line in slope-intercept form is y equals mx plus b. In this case, we already have this form of the equation. So for problem one, we know the slope is equal to 4, and the y-intercept is the point 0, -2. And you know what? Since we think about slope as a ratio or as a fraction, let's look at that 4 in terms of a fraction, and let's call that 4 over 1. So our slope is 4 over 1, and actually let's just make it 4 over 1 from the start. Okay, so we know the slope and we know the y-intercept. The y-intercept is a specific point on the graph. So we know that the point 0, -2, so 0 for the x, 0 in the x direction, -2 in the y direction, would be right here. So that is the point 0, -2. And the slope of 4, or 4 over 1, if we think about it as a fraction, that's rise over run, or vertical change divided by horizontal change. So vertically, we go 4 units, a positive 4, so we go up 4. 1, 2, 3, 4, and that's over 1, so we go to the right by 1. So up 4 over 1 will give us that second point here. So that second point looks like it's at 1, 2. 1 on the x-axis, 2 on the y-axis. And once we have 2 points, that is enough to generate the graph of the line. So this is the graph of the solutions to the equation y equals 4x minus 2. All right, so let's do another one of these problems. And in the second problem, I'm giving you an equation that's not in the slope-intercept form. So we don't know the slope, we don't know the y-intercept. The 3 numbers in this equation, the 2 in front of the x, the 3 in front of the y, and the 12. So the 2, the 3, and the 12, none of those numbers have any significance as far as the graph goes. The only time that the numbers in the equation have significance or specific meaning on the graph is if the equation is in y equals form or slope-intercept form. So the first thing we're going to want to do is rearrange the equation. So we have 2x plus 3y equals 12, and we want to solve for y. So let's subtract 2x from both sides of the equation. So on the right, we will have 3y. So the 2x and the minus 2x cancel. And on the right-hand side, we'll have negative 2x and a plus 12. And we want to get y by itself. So let's divide by 3 to cancel off that times 3. And so we'll have y is equal to negative 2/3 times x plus 4. 12 over 3, or 12 divided by 3, that is 4. All right, and just like in the first problem, now we have an equation in slope-intercept form. So we know the slope is negative 2/3, and the y-intercept is the point 0. The y-intercept is the point 0, 4. So we'll start with the y-intercept because that's a specific point on the graph. So that's up here at 4, positive 4 on the y-axis. And now we'll use the slope. And again, slope is rise over run. Now, if we look at that slope, there's a negative sign, but there's only one negative sign. So that negative sign, it's either going to be connected to the 2 on top or the 3 on the bottom. It doesn't matter which one, as long as we're only using a single negative sign. So we could treat this slope like it's negative 2 over positive 3, or we could treat it like it's positive 2 over negative 3. It doesn't matter where the negative sign is, as long as we're not making both numbers negative. So if we use this slope, where negative 2 over positive 3, well, negative 2 is the rise, the vertical change. So negative 2 means down 2 over positive 3. So 1, 2, 3. Down 2 over 3. We'll put you right there. So we started off with the point 0, 4. And we used the slope negative 2 over 3. And that brought us to the point 3, 2. 3 on the x-axis, 2 on the y-axis. Or if we would have used this one instead, the positive 2 over negative 3. So positive 2 means up 2 units. 1, 2. And then negative 3 means 3 units to the left, which would give us this point right here. And you'll see it doesn't matter if we go up and left or if we go down and right. All 3 of these points fall on the same line. So we did more work here than was necessary because we only needed 2 points. But I just wanted to emphasize that there's, if the first point is your y-intercept, there's not one specific second point you have to use. Just any second point on the graph is sufficient. And so here would be the graph of the solutions to the equation y equals negative 2/3 x plus 4, or 2x plus 3y equals 12. They're the same, they have the same graph. All right, so that does it for this problem set. I hope this was helpful.